Stakeholder. Our stakeholder's name is Edna Davis. She's 60 years old. She's retired right now. And we chose her because she's a paraplegic woman who has mobility issues and needs a wheelchair. She's still healthy, but she needs someone to stay with her and help her climb stairs and do many other household tasks. Edna Davis is a paraplegic woman who needed a smart home device for her mobility needs. She needs a ramp to go up or down stairs with less effort than a normal ramp. She also needs the ramp to be easy to use and safe so she can be less dependent on other people. So our problem statement is disabled people need help doing common tasks around the house because they can be physically incapable. Common tasks like closing the lights or going up the stairs can be hard for disabled people. And our problem statement relates to our empathy/research because we empathize with disabled people so we can help them. And we focused on research that will help disabled people who have mobility issues. Our solution is to make an escalator ramp, and this related to our empathy/research because we were empathizing with a disabled person with mobility issues, and our research was focused on helping the disabled person with mobility issues go up or down stairs. We created an escalator ramp that will help our stakeholder go up and down stairs with ease and less effort. So my challenges and victories. So my challenges, I only had one major challenge, and it was putting the ramp together. We had to put the part of the ramp where you stand on into the base, so the part of the ramp where you stand on had enough tension. We managed to use the hot glue and the wheels with the motors to create the tension. And the victory, I had many victories through our build of an escalator ramp. I had success making the mechanism of an escalator for a ramp. The part where you stand on in an escalator was able to move like an escalator, except it was in the form of a ramp.
For me, I had both two challenges and two victories. For my challenges, I had part shipping and Arduino coding as both of my challenges. Our parts came in pretty late, especially the part that we needed, which was the L298N motor control module, which was pretty crucial in our Arduino wiring. And Arduino coding was really tough, and there's a lot of errors and stuff while we are doing it. For our victories, we had our Arduino wiring was one of our victories, as our Arduino wiring wasn't too difficult, and also while we had to solder some wires, the soldering wasn't too difficult for me, and I felt pretty comfortable doing it.
A challenge I had during the prototype included figuring out how to put the prototype together. And some victories I had included helping produce ideas and successfully building the frame.
We had three main steps when designing and creating our prototype: designing our prototype, building the base of the body, and also working on the Arduino and wiring portion. Now we first started by designing our idea on paper and on Google Whiteboard and found all the parts that we needed. After that, we then finished the design process by making a 3D model in order to make sure that we got all our dimensions right, and so that we had a mental picture of how this would actually look like in the real world. Next, we started to focus on the base of the body because we didn't have the parts in order to continue work on the Arduino. So first, we made the body. We first made the base and the conveyor parts of the body, and then after that, we connected the motors and the wheels. However, when we first connected them with tape, but then we switched to hot glue as it was cleaner and more effective. Finally, we worked on the Arduino and wiring portion of the project last when we finally got the part that we needed and we were finished with the rest of the project. For prototype showcase, we have two different pictures. The one showing the wiring in the Arduino part, and then also showing the main body in the base of the actual build that actually represents our prototype. Now, for our prototype, this is showing the conveyor belt and how it would move up and down, while over here it will show how all the wiring would work and connect together. When we consulted with our stakeholders for feedback, they gave us some pretty important suggestions. They first suggested that we should improve the safety by making the safety doors more secure and extend further out so that they don't only cover the base and the body of the build, but also on the sides as the floor and also on the top of the floor. Next, we have to make the prototype easier to install. This is a problem as when our stakeholders looked at it, they said that it would be pretty hard to implement in their homes, even though they felt like they could do it. So we'd just like to make it easier to install in order to make it for our stakeholders in order to have an easier chance. Number 3, we made it so that it's possible for a stakeholder to operate a prototype alone, because that was one of the main problems and one of the main issues that they were facing. And if our prototype didn't do that, then they would still have trouble and it would still be inconvenient for them.
Some future iterations include adding a type of rail to keep wheelchairs on the conveyor and make sure they can't roll off, making a bigger device that can reach from the bottom to the top of the stairs, and designing it to make it easier to use. For a high fidelity proposition, we would want a larger machine that could keep itself on stairs with sturdy material that could bring wheelchairs up and down the stairs. We would also want to make it so that it can hold the weight of a person with a wheelchair.